Yes. My name is Joe Dvorak. Talking about the project is LIDAR and Photogrammetry to map alfalfa yield and quality using unmanned aircraft systems. This is a project between biosystems engineers and plant and soil scientists. I also have the places we are working with, Dennis Hancock at University of Georgia, and then Jessica Williamson at Penn State, and they're giving us test sites, and then they're going to help us with the extension outreach in year 3. So we are right now in year 2, which gives you an idea of where we're at with this project. So why are we doing this? Ultimate goal long term is to provide farmers with a way that they could have a UAV take off, fly over their fields, and be able to estimate the quality of the alfalfa that is currently there and the yield should they harvest it right then. That would help them with better management practices. We're also looking at not just maybe when to harvest, but if you have wheeled traffic damage after harvest, that you could track that damage and make better decisions on, for example, when you move the bales off. So there's some machine management decisions going on there. Some of the things we're looking at is yield is highly based on density and volume of the plant canopy. And then the forage guys have developed systems like the peak method where the quality of the forage that's actually in the field at the time is strongly dependent on height. And we can detect those using LIDAR and photogrammetry. Photogrammetry, if you're not familiar with that, you take a lot of pictures of an object from multiple angles. You can stitch those together and you end up with something like that, which is kind of hard to see in this picture. But that's a picture of a photogrammetry 3D model. With LIDAR, it's a laser beam, and you can create a scan of the object you're hitting. This is actually looking at alfalfa canopy, and this is right here like one of these cars, self-driving cars that Google has. Right now we are delayed 1 year on the LIDAR system because all the autonomous car people bought them all up. We did get a hold of one this year, so we're going to be flying it, and it's probably a good thing because it was sold out again right after we got it. So what are we doing right now? We've got quadrats sitting out in the field. We put these out in the field, 20 locations. We sample weekly. And right now it's all photogrammetry. Coming up, we're going to be looking at the LIDAR, and then we're going to actually be trying to scan the entire field. When we do these quadrats, we're carefully sampling the quadrat. We're going to be going to a back and forth method on the quadrat. And we're doing comparisons across cuttings across all summer long, and comparisons with Georgia and Pennsylvania. This is where we're at right now with the photogrammetry. You can see this is one of the quadrats. That's just an image from the UAV. This is the model created by the photogrammetry software. We can stitch into a 3D model. We can take that canopy within the quadrat there. This is the 3-dimensional structure. I can take the statistics from it. We are recording all of this data manually. And then the photogrammetry is estimating the height, which is a pretty good match. 68 was what we manually got. 64 was the max height, which is what the photogrammetry predicted. And we're also able to, and now we're going to go through and trying to find descriptors using statistics department, and they're going to help us with predicting the actual yield using that distribution. Where we're at right now, we are looking at the LIDAR. We actually are using some ground testing at the same time. We're going to be doing wheeled traffic testing, and my time's up, so I will stop there. Thank you.